All right, this video is going to go over how to convert equations from polar to rectangular or vice versa. So let's go ahead and get started. Look, the first thing I'll say is if you don't know this right here, you're wasting your time. So make sure you know that. The second thing I'll say is you need to know what your overall goal is. So for example, like if you're going to polar form, you're going to be looking for something when you finish up like that has r equals something, okay? And if you're going to rectangular form, that's like you need to end up with like an equation x equals 5 or y equals something or x plus y equals something. So just keep that in mind. I think a lot of people struggle on this because they don't know where they're actually going. So let's look at number 1. X equals 4. You have to get to r equals something. So you need to use these rules to get there. So basically you can change x to be r cosine theta. Now, remember, you want r equals. You want to isolate this r right here. So like to do that, you're going to need to divide by cosine. So once you get r by itself, you're done. So you could call this 4 cosine theta, or if you brought that cosine up to the top, it'd really be 4 secant theta. So that's how I would have done the first one. Okay, look at the second one. X squared plus y squared equals 49. Again, I need to get to r equals. So I would use these rules. You can change x squared plus y squared to become r squared. But then you don't want r squared, you want r, so you would need to root it right here. And when you root, don't forget you need a plus minus. So this one would be r equals plus minus 7. Okay, let's look at another. Number 3 is just like the one I just did. Let's look at number 4. 5x minus 2y equals to 1. Remember, I'm trying to get to r equals something. So there's really only a couple things I can do here. I can change x and I can change y to be these rules. So here's what this would look like. I'm just substituting like r cosine theta for x. All right, so now you would need to distribute. Remember, you're trying to get r equals by itself. So you need to isolate these r's by taking a GCF out. And then you would just, right here, your last step would be to divide by this whole thing, 5 cosine theta minus 2 sine theta on both sides. So when it's all said and done, you get r equals 1 over 5 cosine theta minus 2 sine theta. And I'd probably leave it like that. Okay, let's look at a couple more. Let's look at this next one, number 5. You got 4x squared plus 4y squared equals negative 3y. All right, there's a couple things you're going to have to do here. The first thing I would do is I would GCF a 4 out. And here's why. If I GCF a 4 out, now I can use a rule change on this x squared plus y squared. I can call that r squared. Like that. So really now I have 4r squared equals negative 3y. Okay, again, when you're going to polar form and you want r equals, you can't have any x's or y's. That's no good. So the next thing I would do is I would use a rule change on this y right here. So that would look like this. I forgot the r. Hold on. Like that. And so now there's a couple different ways you could do this as well. You could send this to the other side and GCF an R out, but right now I would just take an R away from both sides by dividing by R. Because what that's going to do is it's going to give me 4R equals -3 sine theta. And then to finish it, I would just divide by 4. So you get R equals -3 sine theta over 4. That was kind of a tricky one. Well, let's look at an even trickier one, like number 6. Okay, if I was approaching this problem, the first thing I'd realize is they gave me y squared, but they didn't give me x squared. Well, they kind of did when they gave you this right here. You're going to need to FOIL that out. Like that. And so the reason you wanted to FOIL that out is because now you can use a rule change right here and call this r squared. So really you have r squared minus 12x plus 36 equals 36. And I'm going to go ahead and move this plus 36. So really it's going to be like this. Now, you still have an x or a y here. That's not okay. You have to do another rule change. So it's going to look like this. Okay, now that you have all your x's and y's changed out, you can try to start isolating an r. So the first thing I would do is I'd realize both of these things have r, and I could GCF one out. Once you have it fully factored, you can just set each of these guys equal to that 0. So you get like r equals 0, and you get r minus 12 cosine theta equals to 0. Isolate the r on this one on the right. You get r equals 12 cosine theta. So both of these would be my answers, but you got to realize r equals 0 is basically just telling you you have a circle with a radius of 0. So this one's NA. Circle with radius of 0 doesn't make any sense at all. So that's the general gist of all of these. You're going to have to isolate an R. So there's some where you'll have to do some rule changes. There's some where you'll have to GCF an R out. Those get kind of tricky. But in my opinion, it's worse when you go from polar to rectangular. So let me show you some of these. Okay, let's look at number 23. Okay. When we were going from rectangular to polar, we cared about getting rid of x and y and replacing it with like r's and cosines and sines. Well, it's going to be the opposite now for these. You're going to need to get rid of all the r's, cosines, and sines and replace it with x's and y's. You're still going to use these rules, but now they're going to be a little bit harder to see like what to do. So let me show you a couple examples. Like when you look at this problem, r equals 10 sine theta, we don't have like we can't really use this rule yet. We can't use any of these rules yet. So what you have to do, you kind of just have to know what to do, but here's what you gotta do. You gotta make it say r squared. So like to make that happen, you can either square it or you can just hit it with an r. I would hit it with an r right here. Because on the left side, it becomes r squared. On the right side, it's gonna become 10r sine theta. And so like now r squared, well, that's a rule, x squared plus y squared. And then this r sine theta, well, that's a rule, that's just y. X squared plus y squared equals 10y. And then just to clean this up, I'd probably make it equal 0. Like that. But you just have to know to hit it with an r or to square it. You'll see some of the squaring it in a second. Let's look at another. The next one's very, very similar. So we'll jump to 25. R equals 6 cosecant theta. Okay, first thing you need to realize is this is really like 6 over sine theta. Okay? So like if I hit it with an R like last time, yeah, the left side will work out, but this right side is gonna be really weird. I'm not gonna have like an R sine theta that I can change. So that's not the move I want to take here. And if I square, that was weird. Okay, and if I squared it or something, well, that's not gonna work on the right side either. So I need to be thinking that sign on the bottom is really messing me up. What if I times by sine to make it go away? Well, if I do that, I have to do that on the left side as well. So now I really have r sine theta equals to 6, and r sine theta is just y. So again, you kind of just had to know what to do there. That's what makes these so much more difficult than the other ones. Let's look at like 28. R equals 6 tan secant. Okay, the first thing I would do is I'd make it all in terms of sines and cosines. So you'd be here. Now, you can either, on these, you can either think about it as cross multiplying or as timesing by cosine squared, kind of like the last problem. Either way, it's the same thing though. You're gonna end up with, whether you times by cosine squared or you cross multiply, you could do it either way. You're gonna end up with r cosine squared theta equals 6 sine theta. So like I want to do some rule changes here. That's what I'm thinking. I need to do rule changes. I got to get rid of cosine and sine. But this side doesn't have an r for me to do a rule change. And this side, if you look at these variations of the rules, it needs a square here. Well, the only way to make that happen would be to times by r on both sides. Because if I times by r on both sides, I'd get r squared cosine squared on the left. I'd get 6r sine on the right. Well, r squared cosine squared is x squared. And then this r sine theta on the right is y, so it's just like 6y. So you end up with x squared equals 6y. Then if you wanted to clean it up, you could say x squared minus 6y equals 0. You could also get it to like y equals something, but I'd probably leave it like this. Let's look at a couple more. All right, let's look at 32. Even though I think we've already done one kind of similar. R equals 1 over 3 minus cosine. All right, if I approach this problem, I can't just hit both sides with an R because it won't work for this right side. I can't square both sides. So I would probably imagine it r over 1, and I would cross multiply. And if you did that, you would distribute, and you would get 3r minus r cosine theta equals 1. Okay, now r cosine theta is x, this right here. So you could just call this 3r minus x equals 1. So we're getting close, but we still have to get rid of this r right here. So I would probably move the x. So now it's x plus 1 on the right side. And then I would need to get this to say r squared somehow. So I could either square it or hit it with an r. Now, if I hit it with an r, this right side is going to get messed up. So now I'm going to square both sides. Don't forget, the 3 gets squared as well. So it's really 9r squared over here. And I'm going to FOIL this right side out. So it's x squared plus 2x plus 1. And I did that because I had to get r squared so that I could change it. So now it'd be like 9 r squared is x squared plus y squared. So now I'm here. I would distribute. And then I would probably make it equal to 0. So I would subtract this stuff like minus x squared and the rest of it. So it would look like 8x squared plus 9y squared minus 2x minus 1 equals to 0. That would probably be my answer. That's kind of a tricky one. Okay, now let's get to some of the weird scenarios that you might encounter. Weird scenario number 1. They just give you theta, like number 35. Theta equals 2 pi over 3. Well, remember, you're supposed to be using these rules to get x's and y's and things, right? Well, there's no sines or cosines, and there's no r's. So these rules don't work for you right now. So this is a weird scenario where you just have to know what to do. And what you do is you hit both sides with a tan. Because then it's going to become tan theta equals tan 2 pi over 3, right? Well, tan 2 pi over 3 is negative root 3 over 1, or just negative root 3. So tan theta equals negative root 3. I know you're probably wondering, well, where are my x's and y's? Well, don't forget, tan is y over x. And so once you get here, you can clean it up a little bit to isolate the y if you want. So you can times by x on both sides. You would get negative root 3x. So for like these two, if they just give you theta, you have to hit it with the tan. I know, it doesn't make any sense. You just have to know what to do there. Let's look at another weird scenario that you might come across. What about like 37? R equals 4. Well, at least this time I have an R, but I don't have any sines or cosines. So these two rules are out. All I could do is try to get to this rule right here. Well, in order to do that rule, I have to have R squared. So you have two options. You can either square both sides or you could hit both sides with an R. But if you hit both sides with an R, it's going to mess up this right side. So that's not what you want to do. You want to go with the square both sides. Because then you would get r squared equals to 16, and then you could change r squared to be x squared plus y squared. And then to clean this up, you could minus the 16. Honestly, I'd probably just leave it like this, because then I know I'm looking at a circle, for example. Okay. Let's look at a couple more. What if we came across one like number 42? No, let's do 44. If I approach problem number 44, I would see r equals sine 2 theta. Okay, well, now we have a 2 right here, and this is a problem for us. So you have to remember from a while ago that sine 2 theta is 2 sine cosine theta. And you would have to make that change right from the start. Like this. And so now you really need some r's here. You need it to say r sine theta, r cosine theta. So you're going to have to hit it with 2 r's, aka an r squared. The reason you had to do that is because now you could be like, okay, r sine theta, that's y, and r cosine theta, that's x. So now you're here. Okay, great. Well, now what? Honestly, now I would take an r out on the left side. And I would do that so I could use a rule, x squared plus y squared. All right, and now if I got to here, I would probably divide to isolate r on the left side. And now we're not done yet. You still have to change this r somehow. I would square both sides, because then it would say r squared on the left side, and I could change it to be x squared plus y squared on the left. On the right, I'm going to actually square the top, so 4y squared x squared. And on bottom, I'm just going to leave it x squared plus y squared squared for now. So you did it. You got rid of all the x's and y's. I mean, all the sines and cosines and r's. Now you're left with this very not nice equation. If you wanted to clean it up a little bit, you could basically cross multiply. So you have x squared plus y squared to the 1 times x squared plus y squared to the 2. That's going to make x squared plus y squared to the 3 equals that 4y squared x squared. I'm going to change it to be x squared y squared just so it looks a little nicer. And then you would subtract to make it equal to 0. And this would be my final answer. Now that problem on a scale of 1 to 10 is like a 9, okay? That is a very, very difficult problem. So if you got kind of confused as I was going along there, that's okay. That problem is very, very hard. All right, let's look at one more and then we'll call it on this video. I'm going to look at the most common one. The most common is when it's either just like one function, r equals one function like this, which I've shown you how to do, or when it's like a rational type look to it. So I don't know why this is popping back up, like 32, which I think I did as well, but let's do another one. So I'm going to do 52. This is, in my opinion, one of the most common scenarios that you're going to be thrown into. And I don't want you to forget how to do it. So when you approach this problem, imagine it r over 1, and you cross multiply, and you'll distribute. So you'll get 2r minus 3r sine theta. That's this cross multiply. Then this cross multiply would just be equal 6. Now, you need to make the change on the r sine theta. If you see a change to make, take it. So 2r minus 3, r sine theta is y. Now you're left with still one more r. That's a problem for you. So isolate it. 2r equals 3y plus 6. I just moved the 3y over. And the reason you isolate it is because then you can square both sides. So on the left, it's going to make 4r squared. On the right, you're going to have to FOIL it. Like that. And then once you get here, you did all this so that you could change r squared on the left side to be x squared plus y squared. Distribute. And then I'd probably make it equal to 0. So I'd be moving everything to the left. So I would have to minus 9y squared, for example. So you're going to end up with 4x squared minus 5y squared minus 36y minus 36 equals to 0. So again, these are tough just because you won't know what to do. Sometimes you hit it with an R. Sometimes you square it. Sometimes you cross multiply. Sometimes you randomly have to hit it with a tan. Yeah, so hopefully this video helped you kind of understand what moves to make for specific type problems. Hope this video helped.